Hello. Hi. Good morning, everyone. And thank you for joining this talk on the DRM MSM display and graphics update. I am Abhinav Kumar from the Qualcomm display team. And along with Dimitri and Rob, we co-maintain the display upstream driver for the Qualcomm chipsets. And thank you to XDC for giving us an opportunity to share, at least from the Qualcomm side, the upstream journey and the current status of the driver, and what are our upcoming features and plans for this. So I think just to give a little bit of the timeline, I think it all started thanks to Rob and who added the first KMS driver for Snapdragon. I think if I go by the commit dates, it was back in 2013, and with, of course, some help from Archit on some of the parts. And that time, the chipsets which were added were the APQ 8064, 8084, the 8916, and the 820. And sometime in 2018, we started on the STM 845 based Chromebook program, and that's where really we landed the current DPU driver, which we are using even today for adding most of our new chipsets. And this was backed up in probably a year after that with the SC7180 and the 7280 based Chromebook programs, which we added the DisplayPort, EDP, and write-back support that time. And now, thanks to the support of the display team members of Qualcomm, Dimitri, Linaro, Rob, and Collabra, SO Mainline, and other upstream community members, this driver is supporting close to 18 chipsets. And this will keep growing, and it continues to grow at a very rapid pace. So thank you, everyone, for getting us so far. So just to share, so between this 2030 and the Chrome program, why there was a bit of a delayed push from our side is like, it's mainly driven partly because, there was a major Android domination of the smartphone market, with all the major SoC vendors going with their own kernels. And obviously that led to the business reasons of not having really any major Android programs with a pure upstream kernel. This, I think, backed up with really fast commercialization cycles of Android phones, all kind of just contributed to this. And the Chrome program was some sort of really like an inflection point for us to get all this landed, and thanks to like Rob and Sean Paul from the Chrome OS team to help us really land the DPU driver that time. And so why are we doing this now? The obvious question is why the Qualcomm push since last 2-3 years. So first, obviously the first reason is the continued support for all the compute programs which have already commercialized and the upcoming ones. Then the support for new open platforms. This is like an umbrella term we are using for all the IoT programs or the IoT projects or the new XR programs which are coming up with the pure upstream Qualcomm driver. Definitely the Android GKI was a big factor as well, the generic kernel image project of Android, where it was, I guess, according to the stats, it was estimated that the vendor-specific SoC code in the kernel was at one point contributing almost 50% of the product kernel. So I think definitely this project was aimed to keep the ACK or the Android common kernel as clean as possible, and that's why we wanted to upstream probably the framework changes we did, and that work is still going on. And obviously on all of this, since the foundation was built, we wanted to carry on all this good work moving forward. So coming to the current driver strategy that we have, this can be broken down to just these topics from our side. First is definitely to keep enhancing the DPU feature set. This is definitely not easy, and probably when Dimitri comes over, he will cover the feature set, and we'll talk more on this. But we have done a lot of work last 2-3 years on reducing this feature gap between our upstream and downstream kernels, and we are now in a much better shape than we were, and it's only going to improve moving forward. Then the second aspect to this is that we have an MSM bug tracker now to report any bugs from the upstream community. We have a very vibrant community which continuously validates the phones that they have, the devices that they have, and report the bugs back to us. I think they had already been discussing the bugs on the IRC channels, sharing the logs, sharing the images, but having this, the GitLab bug tracker definitely adds more accountability even for the Qualcomm side to fix these bugs. So the discussions can get lost, but the bugs won't. So I think please feel free to open and raise the bugs. We'll try to support them as quickly as possible. Then I think the second thing which we were focusing on was, I think we now have an IGT-based CI in place thanks to Collabora and Rob's efforts. I think we take definitely a lot of care to keep the IGT CI failures in check. We have been contributing quite a bit in the IGT side last couple of years now, and we would definitely keep doing that. We would definitely want to limit those failures. I think thanks to Mark, I think from Google, there is an IGT channel which he started on the IRC for a collaboration between the major vendors to talk about the IGT bugs and features. And so thanks to Petri as well, who has been quite active in reviewing the Qualcomm patches for IGT. And we have been able to keep enhancing the IGT for the Qualcomm's needs as well. So this will only continue because this definitely provides us not only a good way to keep regressions in check, but also a simple way for us to validate our features for the currently already upstreamed UAPIs. And this has worked pretty well for us in adding some features quite recently as well. And last but certainly not the least, we want to enhance the current DRM CI by adding more boards to it. Just a couple of weeks ago, we added the SM8250 based RB5. This was definitely a new experience for us to add a new board, and we'll definitely use that to keep adding new ones to extend the coverage of the CI even more. So I think now I'll hand it over to Rob to cover the graphics update and also share a little bit on the CI, and then followed by Dimitri.
All right, thanks. Let's see here. All right, so just a quick status on the GPU side of things. These days we have about approximately 30 models of Adreno GPU supported, dating back to Adreno 200. And that's including Adreno 730 and 740, which are landing in 6.7. We've been using for a long time dev core dump for capturing GPU state when there's a GPU hang. And that's integrated in, for example, Chrome OS crash telemetry. And that's been very useful for catching and tracking down and debugging long tail issues, like the issue where the device crashes every like 40 or 80 hours of use. That's kind of something that's difficult to reproduce in person, but getting some information about the crashes has been pretty useful. We're using these days DRM GPU scheduler for job scheduling, and we do, I think, well, at least until Dimitri's Shermem eviction patches land, we're the only ARM driver that supports full gem eviction. And the reason that's important is that Chrome OS tends to make inexpensive devices which don't necessarily have a lot of RAM, and Chrome OS leans pretty heavily on ZRAM swap to make that work. So you have a 4 GB device with 20 tabs open. You might have just only a small fraction of your gem objects resident in memory at any time. So recent work has included user space IOV allocation, which was originally motivated by the Vert GPU native context, because it allows the user mode driver and the guest to not have to wait for a response from the host on buffer allocation. But more recently, it's used by Turnip as well in the non-VM case. So recently, I've been working on partially in DRM and a little bit outside of DRM, dealing with all of the runtime PM and PMQoS issues with lock depth in the fence signaling path, mainly locking interactions that runtime PM or PMQoS have with FS reclaim, and untangling those with the goal of eventually enabling the fence signaling annotation, so we can be confident that we're not introducing new potential sources of deadlock against the shrinker. And then there's been some recent submit octal overhead optimizations. So upcoming work, one thing I'm interested in is a user pointer with potentially a slight twist of not necessarily being virtually contiguous in user space. What that would let us do eventually is allocate memory with guest pages. So one of the, it is kind of expensive when you're running in a VM to map new memory into the guest. If we could allocate gem objects with existing guest pages, that would make that much faster. The problem is, unless the guest pages are physically contiguous from the point of view of the VM, they're not going to be virtually contiguous in the VMM. But if we had a UAPI where we can allocate a user pointer buffer with virtually discontiguous memory, that's no problem to map to GPU virtually contiguous. That would solve that problem. And then the other big one, of course, is VM bind. The interesting thing to solve there is, like I mentioned, Chrome OS leans heavily on eviction. So having something where you have to swap in all of the buffers of a single process would be prohibitive. So would end up meaning we need the existing stuff and the new stuff to coexist side by side, instead of the legacy stuff just being a compatibility layer on the new stuff. So figuring out how to make that work is something I got to work through. So can I get to the next slide? There we go. So on the DRM CI, DRM has recently been embarking on the GitLab CI adventure. And these days we have a combination of devices in the FD farm in Portland and in Collabora's farm, and now in Qualcomm's farm with the SM8250. which are running kernel CI. So the way we're using this for now is Abhinav, Dmitry, and myself will collect patches from the list and push a GitLab MR, which triggers CI, and targeting either MSM next or MSM fixes. And this lets us have some confidence that we're not breaking things, especially with so many different platforms out there. So hopefully over time we can add more. So I think off to Dmitry.
Yeah, thank you. So unlike the previous, unlike the talk, I am mostly looking at the display side, not on the graphic side. So yeah, Abhinav started with this part of the talk. We have through display backends in our driver that lets us to support different generations, different Qualcomm chips. The MDP4, the oldest one, that initially started the whole process was done by Rob Clark, and it was done at 3.12, and it supports on the oldest generation. Yeah, if you have something older, please come to us. We would like to have that hardware. MDP5 has the middle generation. It is now in the maintenance only. It covers the hardware that was on the market until 2017 or 2018. But it is now mostly in maintenance mode, but you can see that there are still platforms being added. And 8226 is one of the eldest platforms that can be supported by this subdriver. So yeah, the growth was was steady. It is now again in mostly maintenance, but if you have older devices, maybe it's now time to take a look at your old Qualcomm phone and start checking what can be done there. Thanks to the work done by Postmarket, by SOMenline, and by other community teams. So that's a great time to take a look. The DPU is the newest driver. It was initially done by Qualcomm. It was incorporated into the kernel thanks to Qualcomm and Chrome OS. And this is where most of the current work goes. There was a slow start for it, but now we have a pretty significant growth. So if the previously time between the platform announcement and actual patches for that platform going in was like, it might be up to years. For the latest platforms, we have a time between platform announcement by Qualcomm and patches going into the mailing list up to 2 months or less than 2 months. And for the next platform, we actually try, and the plan is to post patches and provide support for the new platforms just at the announcement day. So this is kind of a significant change that was possible thanks to Qualcomm, thanks to all the community, etc. So some stats: the MDP5 driver was done par on par by the Qualcomm and by the community. For the DPU driver, there are three major players. It is Qualcomm, it is Lenaro, Truly, and the community, which contributed really a third of all the supported platforms by the DPU driver. So again, current features, what we currently do, what we currently plan to do. Of course, DSI, yeah, the heart of most of the phones. So we support both normal single-link DSI and bonded DSI, or dual DSI, as you might know it, where two DSI hosts drive the same panel. We now support both command and video panels. So if you had previously issues with your phone and that was the only issue why you did not try upstream, please try and report bugs. We would really like to get all your Qualcomm phones or Qualcomm-based phones to be supported by the upstream. DisplayPort, that was kind of a new stuff in the last several years. And thanks to latest laptops also getting the EDP instead of DSI panels. Yeah, this is one of the main topics now. It is where we currently we have one of our focuses. Qualcomm provided the driver that has 0 failures on the CTS. It passes all the PHY, link, and test pattern test suits. So it is good, it is great, and it is. We are trying to get it to work on most of the platforms. So I was questioned if we can use it on the development kits. Yes. So for example, the latest development kits work with Linux Next with just a single patch for the DisplayPort. So it was not there that way a year ago. And of course, HDMI, some legacy platforms support HDMI natively, so that's useful. We have one of the, well, that kind of correlates to the to last talk yesterday. We are heavily using DRM bridges and DRM bridge connector in our pipelines. So there is a huge path for the signal to travel, and it is covered by the several bridges. They differ from platform to platform, and for each and every configuration, except the eldest one, except the LVDS, there is a DRM bridge and DRM bridge connector. CTM, yep, there is a color management support. For now, we do not support gamma to gamma, but Qualcomm is looking at it, and we are, so both Qualcomm and Linaro is heavily following the upcoming discussions regarding the plane color management and high definition rates images. Write back, yes, Qualcomm added support for the write back, and initially it was done just for 2 platforms for Chrome. Now it is getting supported on most of the platforms where we can do it. So it is a way to easily test. You do not have to resort to CRC, but you can really get the image, check what is there, and I think that will be also important for the HDR. So this is useful. Our platforms have got the EDP PSR support. I think we're one of the first users of the PSR framework, and it was kind of a hard path for us, but it is now done. Please test it. Feel free to use it, and feel free to tell us where we were wrong. So DSC, display stream compression, currently it is supported only on the DSI panels, but we support DSC 1.1, 1.2, depending on the platform, depending on the panel. And I should be proud to say that DRM MSM was the driving force behind adding DSC for the panels for the DSI. And of course, last but not least, is the core dump, a def core dump. So pretty much like the GPU, which can capture the state of the GPU when the hang is detected in the GPU. Display stuff also can capture the def core on if any of the issues on the timeouts or on the display, and then it helps a lot to analyze your logs. So yeah, send the core dumps. That's nice. Yep.
Oh yeah, just to continue with the feature list, I think like Dimitri already mentioned, we definitely are monitoring the color pipeline proposal very closely. I think one of my teammates has already been active on the RFCs posted by AMD and Intel. We participated also in the workshop which happened on day 1. So certainly we will aim to prototype our solution based on the color pipeline RFC which has been posted, and definitely give our feedback and comments to improve it based on our needs. Then the next one is the concurrent write-back support. So to build on the write-back, this concurrent write-back will be used in concurrency with the same primary display pipeline. That's why it's called the concurrent write-back. We will definitely aim to, we have some plans in mind for this as well, so we'll start work on this too. So the DP-MST is something we had been thinking of, but just over, the DSC stuff got pushed out earlier than this one. We know, and I personally attended last year's XDC and saw the demos from AMD, and we know that there is a good level of confidence in their Intel and AMD's MST solution. That also gives us a good starting point to start our support, and hopefully we'll get this added soon. The next two are the panels features. So I think Qualcomm has significant expertise with MIPI panels, and thanks to the smartphone market for sure. And then one of the couple of features we are keenly interested in is one is the command mode, video mode dynamic switch, because some panels support both modes, and depending on the use case, we would like to be able to switch the modes on the fly. And we had been having some discussions on and off on the IRC channels with Linaro on our sync ups, and we would like to push out some RFC at some point, hopefully soon. And then the next one is the simulation panel framework for DSI panels. So I think for the external displays such as the DisplayPort, HDMI, there is a good Chameleon framework in place to kind of simulate all the monitors by having their EDITs. But for MIPI panels, we would like to have a simulation framework in place, because it is not possible to have every panel in-house to test it out, and it is both logistically and from the economic point of view, we need to have some kind of simulation in place to be able to validate the DSI call flows and probably even the performance metrics with various types of panel resolutions and the various modes as well, like command mode and video mode and so on. So that's definitely on the list. YUV output over DP is another thing which is should be out shortly. We are definitely planning to get this done very, very soon. We know we have seen some solutions in the upstream in place, so ours will be out soon as well. And last but not the least, the DSC over DP as well. We also have this pretty much complete now. This will also be out on the list probably in the next month or so. So these are certainly some of the things on this list are things you will see on the DRI development list pretty soon. So.
This is the features that we are targeting out. One of my colleagues has said a year ago that, it's no longer interesting to bring up new Qualcomm platforms. It is just easy peasy. We can do it in several days or several weeks. Yeah, okay, several weeks, not several days. But on the other hand, it allows us to focus on a more generic and more integration part of the stuff. So 2 years ago on the Linaro Connect, we have introduced the virtual planes, the way for us to try to drive the actual hardware by not tightly binding the hardware backends for scaling the buffer, for scanning the buffer and the DRM plane for different reasons. And for one of the reasons is that a single hardware block cannot. On some platforms it cannot support 4K resolution, but the rest of the hardware and the platform itself can support 4K. So that was one of the reasons. And also it allows us to have more versatile configurations. So like having more panels that are hardware blocks, having less panels that less planes that hardware blocks, switching between these modes natively, transparent to user space. The first patches have landed. We got a 4K proper on these platforms, but now we are really trying to get the most that we can get from the hardware by using and reusing the hardware blocks and getting more, twice as many planes as there are hardware blocks. And this will be completely transparent to user space, so no need to worry. The only thing that if you overcommit, you will get an error from atomic commit, that's all. From atomic check, that's all. DSI, yeah, so it is pretty good. It has been in the kernel for quite a long time, but there was an issue that has been there for as long as there was support for DSI. DSI doesn't fully fit into the DRM's thought of the states, and it has the third state where the link is already up, but there is no video signal, and there is no place for that in the DRM framework. There was a solution that was upstreamed last year by Dave Stevenson that introduced this pre-enable pre-first and prepare pre-first. But yeah, we switched to using those flags. And if you missed the talk yesterday, yeah, they switch the order of the callbacks in the bridge chains. So instead of just going from the end to the encoder and back, they allow you to trick some of these callbacks and to say, okay, let's enable the DSI host first, and then the panel will be able to send comments. But actually, at some point during this development cycle, we faced a problem. Okay, There is a panel driver, there is a DSI host that they should work together, but neither of them knows if the DSI panel uses this flag, if there is actual, if the panel expects to be powered and at which point. So we are now trying to get this sorted out by explicitly telling, okay, yes, dear DSI host, please switch up, please switch on, please power on the link. We want to send comments. So this is on the mailing list. I would like to hear your comments. Yep, that's it. DisplayPort, yes, as I said, it is already there. It is mostly working, and we are working now on getting to work with the user space, so that user space is notified when there is actually it is a DisplayPort or it is a USB-C. What happens? What is the dongle that is connected? Which port corresponds to which? Which Type-C port corresponds to which DisplayPort, etc. So there was the patch that was landed thanks to Intel. There are several problems with it, so we are looking and working on getting the user space API in a more sane state. Last but not least, we are also working on blending improvements, so like getting more planes, using less bandwidth, thanks to precious hardware features on the Qualcomm chips. So that's it. Some stats. There we have a large amount of contributors through the whole history. We have, I've listed largest contributing parties. Of course, it is topped by Qualcomm, but it still has other parties. So for some of them, it is just patches because one of the maintainers or one of the guys was fixing or redoing stuff. We would like to point out to a Assembly Line that is the community project done in a spare time by poor guys that have Sony phones and rich guys that have Sony phones, and they work a lot on getting them up and running with upstream. So that's great. Other than that, yeah, that's it. So I will not name the names. You see them, and some of them are pretty much known. So, yep, that's it. Okay, it seems there are no questions, so thank you for listening. And again, if you have a Qualcomm phone, Qualcomm phablet, yeah, please give it a try with the upstream. Most likely, we can get it either to work, or either it will work, or we can get it to work pretty easily. Or if not, that will be very interesting for us to lay our hands or to lay our minds on that platform. So thank you.
Thank you so much.